Talk about chronic inflammation. And this is an important topic because, as we'll see as we go through the semester, many of the disease processes that we will talk about, one of the key features of the underlying mechanisms of the development of these diseases is chronic inflammation. So chronic inflammation is a very important concept. And basically, it builds greatly on what we've been talking about in terms of acute inflammation. So, before we dive into chronic inflammation, let's talk about what are some of the possible outcomes of acute inflammation. So we know that acute inflammation is triggered by the presence of a pathogen or some sort of injury to the tissue. Now, ideally, in a perfect world, acute inflammation is triggered by, let's say, injury, but specifically it's going to be some sort of acute injury. So it's an injury that occurs and then goes away. Okay? And that could include infarction, which suggests that we have some sort of lack of blood flow to an area, and it causes death of the tissue. Bacterial infections, and in this context, we're talking about bacterial infections that occur and then are cleared by our immune system. The presence of toxins or some sort of just acute trauma. So we get, in response to this acute injury, the short-lived injury, we get acute inflammation and all of the things that we've already talked about. We get those vascular changes, vasodilation, increased permeability. We recruit neutrophils to the area and then monocytes and macrophages, and we have the release of the cascade of mediators that triggers inflammation. Okay. Now, in an ideal world, the outcome of inflammation, acute inflammation, the best outcome is something that we call complete resolution, which means that after that very explosive acute inflammatory stage, we get into the calming down of the inflammation, and we end up with completely clearing what initially stimulated the inflammation, so a complete cessation of the injury. We have a complete clearance of inflammatory mediators. Okay, so we completely clear the inflammatory mediators. We completely clear inflammatory cells from the area. We completely regenerate and replace the injured cells, and we have totally normal function returning. Okay? So complete resolution means that after the healing phase is complete, the tissue looks exactly as it did before the injury occurred. Okay? So that's complete resolution. Another possibility is that we have to actually go through what's called a pus stage, okay, or the formation of an abscess before we can heal. Now, we form an abscess when an injury or an area of inflammation gets colonized by certain bacteria. So there are some bacteria that are particularly difficult to clear from an area. Okay? And so their presence causes the continued recruitment of neutrophils. And of course, we know that when neutrophils get there, they're going to die. And so when dead neutrophils congregate in an area, they actually cause what we see as pus. So an abscess is a collection, a massive collection of dead neutrophils. And as I said, certain bacterial infections are a little bit harder to clear, and so they tend to cause an abscess. So when we go through this abscess stage, healing tends to result in fibrosis, okay, or scarring, basically. So this is healing through the formation of scar tissue caused by the formation of an abscess. The third possible outcome is that healing occurs without the formation of an abscess. Healing of the tissue occurs through the formation of scar tissue. Okay. Now, this happens, for example, in tissue that cannot regenerate injured or dead cells. And a classic example of this is myocardial infarction or heart attack. The myocardial cells, cardiac muscle cells, cannot regenerate. You cannot produce new cardiac cells. And so when you get enough of an injury that causes death to those cardiac cells, healing occurs through remodeling of that tissue, which involves the formation of fibrotic scar tissue. Okay. The third possibility, okay, the fourth possibility of outcomes of inflammation is that acute inflammation progresses to chronic inflammation. And essentially what causes chronic inflammation is an injury that is not acute. It's an injury that is persistent. Okay? Because in the face of a persistent injury, you have the conflicting events going on of active inflammation and attempts to repair the tissue. Okay? And those two sets of events, active inflammation and attempts to repair the tissue, completely conflict with one another. Okay? And so if chronic inflammation is not interrupted, it will result in the healing through the formation of scar tissue. Okay? And the problem with forming scar tissue is that the fibrotic tissue that remains does not have the same functional capacity as the original tissue. Okay? So when we heal through scar tissue, we lose the function of that tissue. So when I mentioned that the heart muscle only heals through the formation of scar tissue because it can't regenerate, that portion of scar tissue in the heart cannot contribute to the heart function. It doesn't contract and create force, and so it cannot contribute to the function of the heart, which means that the overall function of the heart is going to decline. So that's really the problem with healing through the formation of scar tissue or fibrosis, is a loss of function of that tissue. Okay. So this is another way of looking at what we just mentioned. So inflammation is triggered by injury, okay? And ideally the injury is acute, which means that the stimulus, the injury, is removed. And when that happens, depending on the type of injury, the scale of injury, and what tissue is affected, we can have either complete resolution, which involves a lot of regeneration. And this happens quite often to minimal superficial skin wounds. So we get lots of scratches and scrapes and small wounds on the surface of our skin that seem to heal, and there's no trace of the injury ever again. Okay? Also, liver tissue is highly regenerative, and so the healing of the liver in response to acute injury is complete resolution, and we completely regenerate that tissue. We heal through the formation of scar tissue when we have very deep skin wounds. So all of us have scars of our wounds on our skin, and those are usually very deep or very large wounds where we couldn't regenerate all of that skin epithelium, and so we've formed some scar tissue to fill up the hole. Okay? And of course, myocardial infarction is the example I gave, the heart attack example, where the heart cannot regenerate any of itself, so it has to heal through the formation of scar tissue. And then in the face of persistent tissue damage, no matter what the tissue bed is, no matter even the liver, right? In the face of persistent tissue damage, we get chronic inflammatory responses, and if that process is not interrupted, we end up with fibrosis, okay? or a tissue scar and a loss of function. And this is what we see in cirrhosis of the liver. This is what we see in chronic pancreatitis, in pulmonary fibrosis, and many other diseases which we will go through as the semester progresses. So what are some of the common causes of chronic inflammation in our body? Number one, persistent infections. There are some microorganisms that are particularly difficult for our body to remove, to completely eradicate. And so they tend to cause persistent injury to these tissue beds. And that includes infections such as the infection that causes syphilis, certain viruses like the hepatitis virus, certain fungal infections, and certain parasites. Okay? So persistent infections can cause chronic inflammation. Prolonged exposure to potentially toxic agents. Okay? And this is a very all-inclusive category, right? So potentially toxic agents, which include endogenous or exogenous. So for example, someone who has chronically elevated plasma glucose, okay, that is an example of an endogenous toxic agent. Hyperglycemia, chronic hyperglycemia, causes chronic injury to tissue, okay, a variety of tissue. Okay, so that's an example of a cause of chronic inflammation. Chronically elevated cholesterol. Okay? Chronically elevated cholesterol is also an endogenous toxic agent. Okay? And then chronic alcohol abuse is an exogenous agent that chronically damages tissue, including the liver. So these are all things that we are exposed to. They're either from an endogenous or an exogenous source. And if we have a prolonged exposure to them, they can cause chronic injury, which causes chronic inflammation. And then lastly, a very important example or cause of chronic inflammation is autoimmunity. Okay? And with autoimmunity, you get a chronic activation of the inflammatory response because your body is reacting to some sort of self-antigen. Okay? And since the self-antigen isn't going away, it constantly triggers a chronic inflammatory response. So let's look for a second at what happens in a normal acute inflammatory response, and then what goes wrong in a chronic inflammatory response. So in an acute inflammatory response that occurs in some tissue bed, okay, so over here we've got a capillary, right, blood vessel capillary. Over here we've got a lymphatic vessel. And then over here we've got the interstitial space, okay. And the inflammatory response is going on in the tissue area and in the interstitial space. So the first cells to respond to acute inflammation are the neutrophils. Right, so the neutrophils get there, they release lots of reactive oxygen species, they phagocytize cellular debris and pathogens, and then they apoptose and die. Okay? So the neutrophils arrive and they do their job and then they die. The next wave of cells for an acute inflammatory response are the monocytes that then turn into macrophages. And those macrophages, when they get there, okay, those macrophages start to clean up the mess that's there. They continue the inflammatory response. Okay? They continue to release inflammatory mediators that stimulate inflammation, but they also start to clean up the mess. So they're going to phagocytose the dead neutrophils. They're going to phagocytose the debris and any pathogens. They're going to absorb some fluid and proteins that have escaped out of the blood vessels. Okay? And these macrophages, of course, you're going to get wave after wave of macrophages. So some of the early macrophages are going to also die and get removed by the lymphatic system, or they're going to survive and enter the lymphatic system. Okay? But the early macrophages, the ones that were stimulating inflammation and cleaning things up, are going to leave the tissue. Later macrophages, okay, later macrophages that arrive are going to release anti-inflammatory cytokines and also growth factors. And the later macrophages, once you're in the healing phase of this response, the growth factors are going to cause the production of new blood vessels, the regeneration and repair of tissue. Okay? And even those later macrophages, once they've done their job, they will also leave the tissue. Okay? So what happens with a chronic inflammatory response? Well, the macrophages that get recruited to an area of chronic inflammation, whether they are early macrophages or late macrophages, when they arrive, what they actually signal or sense in the area is the need for ongoing inflammation. So those macrophages, even the ones that are recruited to the area later in the process, they continue to release the pro-inflammatory mediators that continue to cause tissue injury. Okay? And they also release the growth factors and all of the mediators that are designed to cause healing of the tissue. Okay? And so the macrophages that get recruited to areas of chronic inflammation, they tend to release both sets of mediators, and the result is something that is often described as frustrated repair. So you get these attempts to repair the tissue, but because you also have ongoing inflammation, that ongoing inflammation damages those attempts to repair the tissue. Okay. So the macrophages that are recruited to areas of persistent injury and chronic inflammation, they often get immobilized in the tissue. They cannot escape, they can't leave, or they get constantly recruited to the area. And because there is persistent injury, they start to release both sets of mediators, pro-inflammatory and healing mediators, and the result is this frustrated repair. And since all attempts at repair are sabotaged by the ongoing inflammation, the result is, ultimately the end point, is the only tissue that survives is fibrotic scar tissue. Okay? And so the tissue that was once healthy is replaced by fibrotic scar tissue, and you get this loss of function.